This is BTEC Engineering, Unit 7, Section A23 of the Section A booklet on page 42. As usual, this is video, not a lesson. You will need to pause to take notes in order to complete your portfolio successfully. Again, the mathematics involved in this example is very complex. Make sure that at the very least that you can follow through the steps, substituting different numbers for the various steps. So again, as usual, for the last few sections, and will be to the end of section A, we need to find the first and second derivatives of a function. Again, this is a product, so the u is the first function, 1.1 t squared, and the v is ln t. So we use the product rule, and we need to differentiate various functions. So if we've got t to the n, that differentiates to n times t to the n minus 1. If you've got kt, that differentiates just to k. If you've got ln t, that differentiates to 1 over t, and which will become important later on. 1 over t is the same as t to the power of minus 1, which means you can differentiate it using these rules. So, product rules. So, du by dt, we've got t to the n, t squared, so we times by the 2, so 2 times 1.1, take 1 off the power, 2 take away 1, 2 times 1.1 is 2.2, 2 take away 1 is 1, so we'll just leave it as 2.2t. ln t differentiates to 1 over t. We use the product rule for ds by dt, so ds by dt equals v times du by dt plus u times the v by dt. So sticking in the formula, we've got 2.2t times ln t plus 1 over t times 1.1 t squared. Well, dividing t squared by t just knocks it down a t, so we get 1.1 t. So I guess we won't need the t to the minus 1. But again, if we can explain that last bit in a couple of ways. So 1.1 t squared over t, one of the t's cancel out to get 1.1 t, or 1.1 t squared times t to the minus 1, add the powers, 1.1 t to the 1. So we get that for ds by dt. Now we get another product for the first term. The second term is just a straightforward one to differentiate. So d2s over t squared. So we'll do the product first in a box. So 2.2t ln t. So u equals 2.2t, v is equal to ln t. So du by dt. So kt scenario, so we just get the number in front of the t, which is 2.1. V equals ln t, well, goes to 1 over t again. Apply the product rule, so v times du by dt plus u times the v by dt. So v times du by t will be 2.2 ln t. 2.2t times 1 over t, the t's cancel out. Get 2.2. So the first two terms come from that one. So it's 2.2 ln t plus 2.2. 1.1t is a kt, that differentiates to k. So plus 1.1. So we get 2.2 ln t plus 3.3. 2.2 plus 1.1 is 3.3. And we'll need each of those for later. So s equals 1.1 t squared ln t. ds by dt equals 2.2t ln t plus 1.1t. And d2s over t squared equals 2.2 ln t plus 3.3. And that's the first part. So again, make sure you can at least follow it through with different numbers. So the process is the same, a lot of the algebra is the same, just the numbers may be different. So finding gradients t equals 1 and t equals 2. So as always, we just stick the value into ds by dt. So when t equals 1, 2.2 times 1, ln of 1, I need to put it in brackets when we do it in the calculator, plus 1.1 times 1. Get my calculator out. 2.2 times 1 ln 1, close brackets, plus 1.1 times 1 equals 1.1. And then the same thing with t equals 2. So 2.2 times 2 ln 2 plus 1.1 times 2. Stick that in. And 2 decimal places, 5.25. Again, to get a pass, you need to be able to calculate those. To get merit and distinction, you need to explain your method and compare your answers to that obtained at A11. Now you would write, these are the correct answers because they've been found using calculus. Your graphical method answers in A11 were estimates, and you would rate them on how close they are. So if they're very close, they're good estimates. If they're far away, they're bad estimates. Doesn't matter if they're good or bad, as long as you make the right comparison. Moving on to turning points. So we need to solve ds by dt is equal to 0. So in this case, 2.2t ln t plus 1.1t is equal to 0. Now in this case, I like to factorise in order to try and get solutions. So we can take 1.1t out, open bracket, we would get 2 times ln t plus 1 is equal to 0. So we get two possibilities. 1.1t equals 0, which gives t equals 0. That doesn't lead to a solution because you can't have ln of 0. You would have to have had ln of 0. When we plotted it, we got an error for that particular point. So t equals 0 isn't a solution. We have 2 ln t plus 1 equals 0. So basically you've got two things multiplied together, one of them has to be 0. The first one can't be 0, so it must be the bracket. So rearrange, minus 1 to both sides, 2 ln t equals minus 1. Divide by 2. Minus 1 divided by 2 is minus 0.5. And basically we need to find t. To undo ln, the inverse of ln is e to the power. So t would equal e to the minus 0.5. Now basically, if you've got ln t equals any number, t will be e to the power of that number. So you will need to be able to do that. So e to the minus 0.5 is equal to 0.606,503,06597. I'm just having it long for finding the s. Need to find s. So s equals 1.1 times t squared, so 0.606 dot 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 squared, ln of 0.606 dot dot dot. Stick that into the calculator. And we get minus 0.02333696. So to two decimal places, 0.61 minus 0.20 to two decimal places. We need to find out its maximum minimum by sticking it into d2s over t squared. So d2s over t squared equals, remember putting the t value in, so 2.2 ln of, we'll need the brackets this time for the calculator, 0.0 0.606 dot dot dot, put the whole number in, close bracket, plus 3.3. So stick that into the calculator. So 2.2 ln of 0.606 5306597, close bracket, plus 3.3 equals 2.2. Amazing. Wasn't expecting an exact answer. So 2.2, which is positive, so the point is a minimum. So remember, for second derivative, positive, point is a minimum, negative, point is a maximum. So again, very complicated stuff, but make sure at the very least you can follow it through with the numbers you happen to have from your question, because that'll be the only difference. To get a pass, you need to follow through the maths. To get a merit distinction, you need to explain your method and compare your answers obtained by the graphical method. So that's what you need to compare, that's your point. If it's close, it's a good estimate. Far away, it's a bad estimate. Doesn't matter if it's good or bad. Just make sure you make the right comment to get the marks. Best of luck.